So we have an example of an improper integral. So we want the integral from 0 to e of the natural log of x squared dx. What makes this improper is that to integrate we need continuity, and we don't have continuity because the natural log is not defined at 0. Natural log of 0 does not even exist. So I have to use my definitions of improper integrals to rewrite this because my lower bound has a problem. E, no problems whatsoever, but 0, yes. So this is going to be the limit as a approaches 0. Now, since we're in the interval from 0 to e, all our values for x are greater than 0, so we're going to be approaching 0 from the right. So we want the limit as a approaches 0 from the right of the integral from a to e of the natural log of x squared, which I'm going to rewrite as 2 times the natural log of x dx. So I have the limit as a approaches 0 from the right of 2 times, 2 is a constant, so I'm just pulling that out, integral from a to e of the natural log of x dx. Now, the natural log of x is not one of those that we can integrate just straightforward, not a rule for that one. So we're going to have to rewrite this, or integrate this, sorry, using some integration by parts. So I have to assign two different pieces. I have to assign u and dv. So I'm going to let u be the natural log of x, and that means that du is going to be 1 over x dx, and I have to assign dv, so there's my u is the natural log of x, and dv is going to be dx. So dv is dx, which means that v is just going to be x. Alright, so this is the limit as a approaches 0 from the right of 2 times all of this. The integral from a to e, the natural log of x dx. By definition of integration by parts, it's uv, which is x times the natural log of x, minus the integral, and I know I have a to e, but I'm going to keep my bounds off there for just a second, minus the integral of v du. So for me, that's going to be x times 1 over x dx. And we'll plug the numbers in there in just a minute. So this is the limit as a approaches 0 from the right of 2 times, and this is x times the natural log of x minus, and then the x and the 1 over x, if you'll allow me, those cancel to just be 1. So I'm integrating 1 dx, and so that's just going to be x. Change the color back. That's just going to be x, and I'm evaluating all of this from a to e. So I'll put my bounds in there now. If you want to put them up, I just want to make sure you remember that you got to plug in a and e to the x times the natural log of x as well. So don't forget to do that. All right. So now I have 2 times all this. So again, the 2 is just a constant. It's just there along for the right. So I'm going to plug in e, then I'm going to plug in a. So this is going to be the limit as a approaches 0 from the right of 2 times. I'm going to plug in e, and that's going to become e times the natural log of e minus e, that's my upper bound, minus my lower bound, so minus a times the natural log of a, and then the minus and the negative make that a plus a. When I plug in all my values there. So the natural log of e is 1, so this value right here is 1. So I have a positive e and a negative e, so those are going to cancel. So what this turns into is the limit as a approaches 0 from the right of 2 times, and I have a minus a times the natural log of a. Alright, so now I have to work on these two pieces as far as trying to take their limits. So this is the limit as a approaches 0 from the right, and we'll put the 2 in there, of 2a minus 2a times the natural log of a. So this first piece is no problem. I can just plug in 0 right here and plug in 0 right there, and that turns into 0. So what I'm left with trying to figure out is what's the limit as a approaches 0 from the right of negative 2a times the natural log of a. Because again, I can just plug in 0 right there, and that will become 0, and that'll disappear. So I'm just left with this last part down here, trying to figure out what's the limit as a approaches 0 from the right of negative 2a times the natural log of a. I cannot just directly substitute 0 into that piece. If I directly substitute 0 into that piece, what I'm left with is an indeterminate form. I have a 0 times, and then if you're approaching 0 from the right, the natural log of a, you're going to negative infinity. So that's an indeterminate form. I can't do anything with that. Also, I can't use L'Hopital's rule like that, because that's not an indeterminate form for which I can use L'Hopital's rule. So I'm going to have to do some rewriting here. So this is the limit as a approaches 0 from the right. I'm going to leave the negative 2 times the natural log of a where it's at, and then I'm going to rewrite a as 1 over a down in the denominator. And if I do that, then I have a form that I can use. I have the top, which is going to be a form of infinity. I have a negative infinity times a negative 2, so it's actually going to be a positive infinity. So I have a positive infinity over a positive infinity if I'm approaching 0 from the right. But again, either way, it's not going to matter. I just have an infinity over infinity, which is what I needed. All right, so now I can apply L'Hopital's rule on this line here. So this is the limit as a approaches 0 from the right. Derivative of negative 2 times the natural log of a is negative 2 over a, and the derivative of 1 over a is negative 1 over a squared. And again, that was applying L'Hopital once I had it into a form that I could deal with. So this is the limit as a approaches 0 from the right. This is negative 2 over a times a negative a squared over 1 if you invert and multiply. So I can reduce that, and this becomes the limit as a approaches 0 from the right of a positive 2a. Alright, so now I can just directly plug in 0 to that. So plug in 0 to that, I get 2 times 0, which is going to give me 0. So that means that way back up here, where I started this problem, the limit as a approaches 0 from the right of the integral from a to e of 2 times the natural log of x dx is 0 from what I did there. And again, since that limit is a value, then that means that that integral converges to the same value is basically what you're saying. Since we found the value of that limit to be 0, that means that integral is 0. I put that on the wrong line. I'm sorry. My original problem back here. The integral from 0 to e of the natural log of x squared is equal to 0, because we found the limit to converge to a value. So that integral converges to that same value, which in this case is 0. So I wanted to do that example just to illustrate a few things to you of why this is an improper integral, because of the fact that the natural log is undefined at 0, and also to illustrate the fact that we had to use some integration by parts in that problem to integrate, and we also had to use some L'Hopital's rule to end up finding that limit. So that's a good example. It illustrates a bunch of different techniques that you have for taking limits of improper integrals, and hopefully to help you.